Answers to the end of booklet questions for P2. Question 4. We've got some information here about a heating system. It's switched off at midnight and they provide us with a graph. I've added some information on here as I've read the graph. So I've looked at the scale. I've noticed here at midnight the temperature of the water is, or temperature of the house rather, is 22 degrees. And at 6 a.m. it drops to 10 degrees. Okay. Draw a ring around the correct answer. So I've put a box around the command words here. So we're going to put a box around the answer. Between midnight and 6 a.m, the rate of energy transfer from the house decreases. So what we're saying here is, at the start here, when the heating system switched off, the temperature starts to fall quite quickly. But then over time you can see it starts to level out. So it's falling more slowly towards the end. Here, give the reason for your answer. The slope of the graph levels out between 5 a.m. and 6 a.m. Now, if you want to give more information, you could say, well, at midnight to 1 a.m., the temperature drops from 22 degrees to 18 degrees. Now, if I show you on the graph, here at 1 a.m., the temperature is about 18 degrees. Okay, so I've read the graph there. So in the first hour, the temperature drops by 4 degrees Celsius. If we look at 5 a.m. to 6 a.m., 5 a.m. the temperature is about 10.5 degrees Celsius and it drops to 10 in the last hour. So it only drops half a degree in the last hour. So we can add some information here just to say from 5 to 6 the temperature drops from 10.5 to 10, so half a degree. So it's falling much faster at the beginning and much slower at the end. Okay, so the diagram here shows you a brick wall with a gap and a brick wall with plastic insulation between the layers of brick. The plastic foam reduces energy transfer by convection. Explain why. So our answer is 2 marks for this. The plastic foam stops the air circulating, so you get a mark for saying that, between the bricks, which stops the heat energy moving through the air. So the plastic foam stops the air circulating between the bricks, 1 mark, which stops the heat energy moving through the air. So question 5, electric immersion heater. Used to heat domestic water tank. When it's switched off, the temperature at 58 drops to 50. Okay, first question, A. Complete the following sentence. The main way the energy is transferred through the copper wall of the water tank is by the process of conduction. Remember, conduction is heat passing through solids. And the copper wall of the tank is solid, so it has to be conduction. Part B. The immersion heater has a thermostat to control the water temperature. When the temperature of the water inside the tank reaches 58 degrees Celsius, the thermostat switches the heater off. The thermostat switches the heater back on when the temperature of the water falls to 50. Graph A shows the temperature of the water inside the hot water tank as it changes with time. And the tank is not insulated. And it shows us that at 58 degrees, the thermostat switches the heater off and the temperature drops to 50 in 1.3 hours. Okay, so if we're reading the graph there, that shows us quite clearly what's going on. The temperature of the water falls at the fastest rate just after the heat switches off. Explain why. So the water has more heat energy when it's at 58 degrees Celsius. So more energy is lost at the beginning. At 50, the water has less heat energy, so less heat energy is lost at 50 degrees Celsius. Part 2. To heat the water in the tank from 50 to 58 degrees Celsius, the immersion heater transfers 4,032 kilojoules of energy to the water. Calculate the mass of water in the tank. Specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. So let's look at the information we've been given. We know what the energy is, 4,032 kilojoules. We know the specific heat capacity of water, which is 4,200. That's been given to us there. And the change in temperature from 50 to 58 is 8 degrees Celsius. The equation we will use, and check the equations at the back of the booklet. This one should be there. The energy equals the mass of water multiplied by the specific heat capacity multiplied by the change in temperature. So we know the energy, we know the specific heat capacity, and we know the change in temperature. The only one we don't know is the mass. So let's put all the numbers in and we can start calculating. So 4,200 multiplied by 8 gives us 33,600. Because we are multiplying the mass by 33,600 on this side, to cancel that out, we divide both sides by 33,600. So we're going to divide 4,032 here by 33,600, which gives us 0.12 kilograms. An insulating jacket is fitted to the hot water tank. Graph B shows how the temperature of the water inside the insulated hot water tank changes with time. And we've got another graph. So now we can see that the heat switches off, the heater switches off when the temperature is at 58, and it now takes roughly 3.5 hours to cool down to 50. So that takes much longer. Remember on the last one, 1.3 hours. Okay. By comparing graph A and graph B, explain why fitting an insulating jacket to a hot water tank saves money. So without insulating jacket, the water cools 8 degrees Celsius in 1.3 hours. That's on graph A. With the insulating jacket, the water cools more slowly, 8 degrees in 3.5 hours. So if less heat energy is lost, this will save energy and it saves money because you have to pay for the energy to heat the water.